Good day, guys. In today's video we are going to discuss about this PIR sensor. So what is this PIR sensor? PIR sensor simply means passive infrared sensor. So this sensor over here, what it does is that it is used to detect an infrared radiation generated by human beings or animal. So we can use this sensor to detect human beings or animal. So how did this sensor detect human beings? This sensor detects human beings is the way it detects human beings is that we human beings, we emit infrared radiation in our body, both animal. So whenever this sensor detects that infrared, it will send out a signal. Okay, so this is how we use this infrared sensor to detect human being. So generally it is known as PIR sensor, which is passive infrared sensor. So I'm going to explain how this sensor looks like. This is the real life sensor. This is how the sensor looks like real life. Okay, so I'm going to explain the circuitry about this sensor. This sensor has 3 pins. The first one is the VCC, which the voltage ranges from 5 to 12 volts. Then the middle one is the output, while the third one is the ground. So you can see it has label in this picture. It has a 3 volts regulator. But what I want to point out here is this 2 port, this potentiometer, these 2 variable resistor. You can see this one is used for setting the delay time, and why this one is used for setting the sensitivity of the sensor. So you know what sensitivity control means, how close it will detect the human being before it will send out a signal. So if you adjust it to any small thing to detect the human being, this is where you control this variable resistor here is responsible for controlling the sensitivity of the sensor, while this one controls the delay time. If you want the sensor, whenever it detects an object or human being, whenever it detects human being, the delay time on which it sends out the signal from this output, this is where you set it. So if you want this output to remain high, because whenever it detects human being, it will send out a high signal, which means that this output will become 5 volts. So the amount of delay that this pin will remain at 5 volts is controlled by this port. So if you can set the delay time from 4 minutes, 10 minutes, depending on the range. Okay, so this port is used for setting the delay time, which this output pin will remain high. Okay, while this one is used for setting the sensitivity of the how sensitive the sensor works. Okay, then another thing I want to point out is this yellow cap here. This yellow cap, it has 3 terminal. Okay, and this yellow cap here, it is used, I'm showing you based on if you have the real life sensor, so that you know what this yellow cap here is doing, the work of this yellow cap. This 3 pin here is it has what we call non-repeatable and repeatable. Okay, I'm going to explain the non-repeatable pin and the repeatable pin. So the non-repeatable pin is that whenever this sensor detects any infrared radiation from human being or animal, it will send a high signal in this output. And whenever the delay time you set with this variable resistor exceed, whenever it reaches the delay time you set to this, this variable resistor, then this output will now go low. Even though the presence of the person is still there, it will go low. Okay, that is for non-repeatable terminal. Whenever, because the middle one is the common, while this one is non-repeatable. You can see it, one terminal of this, because it has 3 pin. The center one is for common, this one is for non-repeatable, this one is for repeatable. So the center terminal must be connected to either this or this. Okay, so the non-repeatable is that whenever it detects human being, it will send a high signal. Whenever this delay time you set here using this variable resistor, whenever it reaches the delay time, this pin will now go low. Even though the object is still present, it will go low, after which this time delay time you have set has reached. Okay, but whenever you put it in repeatable mode by changing this cap to the other side, just like the way it is now, this is in repeatable mode. Whenever you put it in repeatable mode, what it will do is that after setting the delay time, which this output will remain high, when this sensor detects an object, okay, whenever it detects an infrared object which we human beings emit from our body, okay, whenever it detects it and this thing is in repeatable mode, this pin will remain high. Even when this delay time that you set have reached, it will still remain high until the object which is present in it leaves the premises before it will now go low. Okay, remember, whenever you put it in non-repeatable, this pin will remain high. After the delay which you have set here reaches, it will go low. Even though the object is still present, it will go low. But in repeatable is that it will go high. Well, even the delay time that you put have reached, whenever the delay time that you use this port to set have reached, it will still remain high until the object in its presence leaves the premises before the pin will now go low. Okay, this is the work of all these things. Then let me show you. Let's go to our Proteus simulator so that you will see how to use this PIR, this PIR sensor in order to detect an object. Okay, not any object that emits infrared radiation. Okay, so this is the PIR sensor in our Proteus simulator, and before you can use this PIR sensor, you must burn in the hex file, just like we did in our ultrasonic distance sensor. Okay, so in order to do that, just let me pause this. It was simulating. So in order to do that, just double click on it. Okay, go to our bin. Because if you have this is the bin. Let me show you something. If you go to this, let me show you. This is the. I'll provide this material which we have already have. This is our Proteus library. Okay, this Proteus library. This all-in-one Arduino sensors. Once you click on it, this will show you all the hex file that contains all these sensors that we are going to make use of. Just copy all of them. Once you copy all of them, then you go to the PCB and your PCB local hard drive and go to the program file 86 if you're making use of 64-bit, and go to Lab Center Electronics folder and go to Proteus 8 Professional. Then go to this bin folder and paste the hex file. Okay, so like you see, this is the hex file of the sensors that we have. So, and we're making use of PIR sensor. This is it. So I'm going to click on the hex file so that Proteus will allow me to use this sensor. Okay, then this is the test pin. We use the logic gate signal. So whenever this thing detects the presence, whenever this pin is high, it will make this output pin high. Okay, so what I did is that I interface it with our Arduino, so that whenever this sensor detects human being, it will send a signal to our Arduino, and our Arduino will perform some tasks. So you can interface it with LCD or anything that you wish to do, but I'm just going to show you the basics of it. That's why I use a voltmeter, DC voltmeter, to show you how this thing sends signal. So I'm going to simulate it now. Okay, so you can see, if you look at this our why this thing is simulating. If you look at this our DC meter, you see that it's reading 0 because it is not detecting any object. But whenever I turn this thing to 1, you see that this our output will go high. Okay, you can see that this output goes high, and this output that goes high will send a signal based on the code that I wrote on our Arduino IDE, which I'm going to explain later. Okay, so it will turn this our LED. Watch what will happen based on the delay they set in this thing. If I turn this thing off, watch how it will delay for some seconds before this thing will go high. You see, I've turned it off, it is delaying. Watch the delay before the thing will go down. This is how it is being produced with this Proteus simulator. Okay, look at, upon this signal is slow now, but it's still delaying. So whenever the delay time reach, this output will go back to low. Okay, so let's see how many seconds it will take before going back to low. So let's wait and see. Okay, so let's wait. So if you look at it now, you will see that this our signal has gone back to low signal. Okay, but it delays for some seconds before sending the low signal. So that is how this PIR sensor works. So let me quickly go to our code and show you how I program this thing. Remember, you can use this PIR sensor without Arduino. You can use it for any other thing, since all you need is a signal from this sensor. But if you want to do some cool stuff, you can integrate it with our Arduino board. Okay, so let me go back to our Arduino. Let me pause this simulation and go to our Arduino IDE and show you what I did, the code that I wrote. Okay, so this is our Arduino, this is our code. So if you look at this code, we just like our normal usual declaration, variable declaration. So this is a global variable declaration. So I use PIR as my global variable name. Then I set the pin to pin 7. So I'm using our input is going to be pin 7, while our output, which is the LED will be pin 6. Then I also declare another variable hold, which will hold the value that our digital read will read from the PIR sensor. Okay, so I use our normal pin mode, set the PIR sensor as input, the pin, which is pin 7, as input, then set the LED as an output. Okay, then we come to our void loop. Then I now use our variable, which is hold, to store this digital read, that the signal that we will be reading from pin 7. Okay, this hold will hold the reading that we are getting from it. Then I now use an if statement, and I say hold equals to high. I remember that whenever our sensor detects any object that has infrared radiation, it will send out a high signal. It will send out 5 volts from its output. But whenever it's not detecting any object, it will send a low signal, which is 0 volts. Okay, so I now say that if this digital read, whenever this digital read reads a high signal, let it turn our LED on. Okay, you can see where I did it. I did the digital write LED high. But if it is not reading any high signal, let it put our LED to low. Now that is where I use this else. If this condition is true, execute it, else execute this one. So whenever the condition is not true, it will execute this one, but whenever the condition is true, it will execute this one. Okay, so this is a simple code I wrote that we are making use of. So if you want to integrate it with an LCD, you can go ahead and do that. If you want to be printing the object that is detecting, that whenever it detects an object, it should send a written note, or it should send a signal that you can be able to read from the LCD. That is left for you to do. So but I'm just showing the basics of how to use the PIR sensor. Okay, so that is it for this video. So in our next video, we'll go to another topic. Thanks for watching. Bye.